Hello everyone, my name is Huilin Zhao. Today we study the functions 11, chapter 1, Introduction to Functions. The first topic is relation and functions. At first we study the concepts. Number 1, the relation a set of ordered pairs. Values of the independent x variable are paired with values of the dependent y variable. 2. Functions. A relation where each value of the independent variable corresponds with only one value of the dependent variable. That means one independent variable value have only one value of the dependent variable. No function. A relation where each value of the independent variable corresponds with more than one value of the dependent variable. The number 2 and number 3 is opposite, right? Number 4, domain. The set of all values of the independent variable of a relation. That means domain is for independent variable. That means it's for x. Number 5, range. The set of all values of the dependent variable of a relation. That means the range is for y value. For the express the function and no function, we have used some weight. There's a notation. Number 1, set. Number 2, table. Number 3, mapping diagram. Number 4, graph. Number 5, equation. For example, the set that here there are 4 pair data, and first one -1, 0. Next is 2, 0, 3. And next is 1, 4. Next and last one is 3, 5. And all data put in the large bracket. And the table right here. The first column, that means is independent variable. The second column is for y value. And here the mapping diagram. The first one, same thing, is the independent variable for x. The second one is for y dependent. The graph is shown here. And put in the Cartesian coordinate system and the job of equation. Next, we're talking about the example. Identify between the function and no function. Number 1, -1, 0, 0, 3, 1, 4, 3, 5. Number 2, -1, 0, and 0, 3, next 1, 4, 3, 5, -1, 2. Last one is -1, 0, 0, 3, 1, 4, 3, 5, 4, 5. We check one by one. And for first set, we have checked the value of x. -1, 0, +1, 3. We can see they are different x value, so we don't need to check the y value again. That means that is we clarify this the function. Yes. This verify this the function. Number 2, there are 5 pair data at the -1, 0, 0, 3, 1, 4, 3, 5, -1, 2. We check the x value. At first, it's -1, 0, 1, 3, -1. We can find the -1 occurring twice, right? So, but they have the different y value. So That means one x value corresponding with more than one y value. So it is no function, right? Number 3 is -1, 0, 0, 3, 1, 4, 3, 5, 4, 5. We can see we can check the x value, -1, 0, +1, 3, 4. So because the x value is different, so we don't need to check the y value again. As verify this function. And next, for example 2, identify function and no function from the relations of the table. The table 1, we can see the first column, this is shoe size 10, 11.5, 9, 8, 7, and height cm. This is 158, 175, 164, 160, 153. Table 2, the first column, the value is 10, 11.5, 9, 9, 8, 8, 7. But the height cm is 158, 175, 164, 167, 174, 160, 153. Okay, we can see the table 1. This have a different x, different y. So I can determine this function. But the table 2, there are 2 9 here and 2 8 here. But the 2 pair for first 9, the height is 164, 7, 9 is 167. So you can see the 1x corresponding with 2y value. So this is not function. Example 3. Identify function, no function for the mapping diagram. We can see the first one. The x is -1, 0, +1, 2. But the y is 2, 4, 5, 6. The different x correspond with different y, one to one. And the mapping diagram for the left side is -1, 0, 1, 2. But the y is 2 when x is -1 to 2. X is 0 to 2. Again, that when x is 1, the y is 5. When x is 2, y is 6. So we can see the result. For the function, the mapping diagram 1 is the function. Because 1 x to 1 different y, only 1, right? And the mapping 2, there are 1 x to only 1 y. And here the same y corresponding different x, that's okay. There is still the function. That means only one x value corresponding 1 y. So it is according to the definition of the function. And example 4, identify function, no function for the graph. We can use the vertical line test. Draw a vertical line, check the intersection point. If only one, that means it's function. If there are 2, there's no function. Like here, the first graph is the parabola and the opening down. So we can see here, drop the line by the x equal 0.5. But the intersection here, there's only one. But for the circle, we draw a line, here is x equals 3, but there are 2 intersection points, so it is not function. Yeah, the first one is function, the second one is no function. Next, example 5. For the equation, number 1 is y equal 2 times x squared plus x minus 4. And number 2, x equal to y squared plus y negative 4. So we can see the first one. First graph, there is the parabola opening up. When we draw a vertical line, we can see there's only one intersection point. So this is a function. But the graph 2 is the opening to the right. So when I draw a vertical line there, we can see the two intersection points. So this one is no function. Also, we can use a decimal to graph. And here we show the result. Like for example, the number 1, y equal to x minus 3. So you can see this exponent of x and y, they all are number 1. So this line, the linear. And number 2, y equal x squared plus x minus 4. So this leading coefficient is positive 1. So this opening up. When we draw a vertical line, we can see there's only one intersection point. And the last one is x squared plus y squared equal 4. This is a circle, and the radius is 2. Right? When we draw a vertical line, we can check that there are two intersection points. So for first one, second one function, and the last one is no function. So is the conclusion. We have which one is function, which is no function. For the function is a relation in which each value of the independent variable corresponds with only one value of the dependent variable. And for the notation of functions, functions can be represented in various ways in words table, a set of a pairing order with order, a mapping diagram, and a graph and an equation. And we have known how to determine the domain and the range for the equation. The domain means all the value of the x as independent variable, and the range is for the y value. All of the value of dependent variable means y. And more practice here, like the number 1, evaluate where fs equal to minus 3x. So like a, b, c, d, e. 1, s is 2, 0, negative 4, 1 over 2, and a you can find is the function's value. When put x equal 2, we can calculate the y is negative 4, and when x is 0 and the y is 2. When x is negative 4, y is 14. When x is 0.5 and the y is negative 0.5. When x is 8, y equal 2 minus 3, 8. And the next we can calculate, just read the graph. And here this graph, and the x-intercept is 0 and -4. And opening down, and the vertex here is 1, 2. There's -2 and +4, right? So we can calculate when x equal 1 and y is -5. The 1 here, x is 1, and y almost -5. When x is -4 on the left side, and here y equals 0. And see, when y equals -3, find the x. Y is -3, 1, 2, 3 here, and then find the x here, almost at the -4.6. First one is -4.69, another one is 0.59. Now that you apply here, you can get the first intersection point here. That means it's -4.69, and the second one here is a positive 0.459, almost. Okay, and next example 3, evaluate for f-1, f3 for number a, f is equal the perfect square of x minus 2 plus 1. B is f is equal to 2 plus 3x minus 4x squared. Okay, this check is number 1, and plot x equal -1 and put the first function. We can calculate this perfect square, -1, -2, minus 1. Is the final answer is 8. And if x equals 3, we calculate the y is 0. And for the number b, plug x equal -1, put the function y equal 2 plus 3x minus 4x squared. So we can get this answer is -5. And when x is 3, when f of x, f3 equal 2 plus 3 times 3 minus 4 times 3 squared is -25. So keep going for number 4. For f is equal 1 over 2x, determine the f -3 and b, f0, c, f1 minus f3, d, f1 over 4 plus f3 over 4. We calculate the 8 question at first. When plot x in the function, we can see this f -3 equal -1 over 6, and the b, if x is 0, is undefined because the denominator equal to 0. So the value of the function is infinity, right? So it's undefined. Number c, f1 minus f3. So put x equal 1. The function is answer is 1 over 2, and the second one is -1 over 6. So it is 1 over 3, right? And the number this number D here. Number D here. When x equal 1/4 and put the function that is here is 2. The second one, when x equals 3/4, this function value is 2/3. So 2 plus 2/3 is a/3. Solution 5. Now, for fs equal 2x minus 5, determine the full quotient. We can get number A, HA equal 2a minus 5. Number B, HB plus 1 is 2b plus 1 minus 5 is 2b minus 3. Number C, x is 3c minus 1, so the answer is 2 times bracket of 3c minus 1 plus 5, so its final answer is 6c minus 7. D, the x is 2 minus 5x, so this 2 times bracket of 2 minus 5x minus 5, so it is negative 10x minus 1. For the number 6, the graph of the right shown here. Fs equal 2 times prefix square x minus 3 minus 2. Evaluate f2, f3, f4. So plug 2 in the function. So this 2 times the perfect square of 2 minus 3 and then minus 2. This answer is 0. And if x is 3 and the value of function is negative 2. And if x is 5 and the function is 2 times perfect square of 2 minus 4 and then the minus 2, this answer is 6. And next question, what does the f3 represent on the graph? For this graph, when the x is 3 here, and the intersection of the graph is here, the 3 and negative 2, right? So that means is the minimum point here. B, state the domain and the range of the relation. Write the domain. There is x belong to a real number. Right? X can be negative, 0, and positive at any number. But the range is for y. Here the y is more than or equal 3. Because this vertex is there the minimum. Right? The minimum here for this one is y. Here is negative 2 here, if for this function. Okay, for this topic, finish. Thank you for your watching and thank you for your listening. You can share the video to your friend. They want to study this course. See you next time. Bye.